My name is Don Carney. I happen to be joined by my co-host here, Andy Forsberg. He's my business partner, one of the co-founders of Fluidity Software. We're both co-founders. I happen to be the CEO. We're going to talk to you today about a tool that is designed, and it's a platform and a tool designed specifically for distance learning and remote teaching. And let me just jump into, it's called FluidMath. Let me jump into a little bit of background about FluidMath to start with, so you know where we're coming from. So FluidMath has its origins in a PhD thesis project that was done at Brown University. We've been around for a while as a company. We took a research project out of a research lab at Brown. That's where I did my PhD. That's where Andy and the rest of our founders all did our graduate work in computer science at Brown. And we took, again, this research project that was a pretty cool tool, had some, what we thought would be very interesting potential for teaching and learning. And we transitioned it from the research lab into the product space for teaching and learning of mathematics. We've been very fortunate to have received funding from the National Science Foundation, the NIH, and the US Department of Ed to take that nascent research project and turn it into a tool that is really effective for teaching and learning mathematics. We've also been fortunate to receive several industry awards, and we've been recognized as a success story from the Department of Education. Our technology is also patented, so many of the cool things you'll see me showing you today are recognized by patent coverage. So if there are any potential partners listening, in addition, I know there are plenty of teachers and educators listening, but there are partners listening, and you're interested in some of our technology from a technology licensing perspective, definitely reach out to us as well. Just before we jump into things, I'll put this slide up again at the end. We're offering FluidMath for free for all teachers and students through August 2020. And the way to get there, and I'll put the slide up again at the end, is to go to fluidmath.net. There's a free trial button on fluidmath.net homepage. Click that, enter a promo code. In the promo code field, it's called, the promo code, you can see it on the screen there, Math UnConference. That's where we are today, the Math UnConference. And if that's for individual licenses, if you happen to be a teacher with a classroom full of kids, or an administrator in a school, or at a district level, and you're interested in more than just one license for yourself, or a trial for yourself, if you'd like to get it for your classroom, or for all the students in your classroom, or at your school, or in your district, please email info@fluiditysoftware.com, and you will be able to see, we'll get in touch with you and we'll set you up with your classroom licenses. So, this is a very interesting time, of course. Nearly every classroom teacher in the United States has been required to turn on a dime and convert your classrooms into online classrooms. So there are some teachers out there who, a couple of weeks ago, maybe their principal or their administrator walked into their classroom and said, maybe it was Tuesday, and they said, okay, tomorrow, Wednesday or Thursday, you're going to be teaching online for an undetermined amount of time. It might be days, it might be weeks, it might be for the remainder of the year. All of a sudden, you have been teaching in the classroom, you've been teaching in the classroom for 5, 10, 15, 20 years, 30, maybe 40 years in the classroom, and now all of a sudden you are an online teacher for distance learning, and you are going to be facing, or you have faced, some serious challenges, and you're still facing those. And math is especially challenging to teach online, because teaching math and learning math is often a very visual experience. And that's because teachers need to be able to show, and students need to be able to see the relationships between mathematical representations. So these things that you have been so familiar with for the past many years, the world has turned on its head. And you are now trying to figure out how to apply those things you've done in the classroom for many years. You're emulating these things you've done in the classroom, but now doing it online. So you're trying to teach, you're trying to give problem sets and practice and activities to your students. Sometimes you want them to play games, educational games in the classroom. And oftentimes you want them collaborating, working with each other to solve problems, because we all know that collaborative problem solving is a 21st century skill. And you also want to be able to assess the students. You want to be able to test them. So there's also other challenges here that we've known really comfortably in the classroom for many years, and that's these synchronous interactions that you have person to person. Now you have to do them over the computer. And I kind of categorize them into 4 groups here. There's the lecture interaction. That's you, the teacher in front of the classroom teaching, and you're talking to your students, and you're asking your students questions, and they're answering you, and they're raising hands, and they're talking to you directly. Then there are, of course, we all know in many classrooms, there are pods or centers of learning that are designed to have students working together to solve problems. So these are collaborative problem solving groups that you have in your classroom. And in those interactions are the students talking to other students, and you're kind of walking around looking over their shoulder, checking out their work. Then there's the extra help scenario down in the lower left-hand corner here, where you say, hey, look, on Thursday afternoons, I have my extra help session, and if you need homework help, or you need help studying for the exam that's coming up, come and we'll work through some stuff with you. That's an extra help session. And then there's the one-on-one type of interaction or synchronous interaction. That's the tutoring example. That's where you're working with one student individually. It may be students with special needs. It may be students who are advanced and studying for an AP exam or the SAT or the ACT. So these are the different types of synchronous interactions that were easy. Well, not always easy, but easier. And you're very familiar with them in the classroom, in person. How do we do this all online? So let me show you what FluidMath is, and we'll discuss some of these things that you're trying to emulate online and that you used to do in the classroom. So I'm going to start by showing you a little bit about FluidMath and what FluidMath is all about. So this is FluidMath. Think of FluidMath as a smart piece of math paper. Whoops, it just disappeared. Here it is. Think of FluidMath as a smart piece of math paper. So for example, and by the way, my face is going to get very close to the screen here. What I may do is I may just turn off my my camera really quickly here. Video, there we go. So think of FluidMath as a smart piece of math paper. For example, I can write some math on the page. 1 + 2. That's pretty simple math, but you'll see it recognized what I wrote, and I can get an answer. 1 + 2 is 3. I can change the math, and the answer updates accordingly. I can change the 3 over here to an A, and then I can assign a value to A. And when I change the value assigned to A, the answer, A + 2, when A is equal to 2, is 4. I can change that again to a 3. I can change the 2 over here to a B, and then I can assign a value to B. And when I change the value assigned to B to a 2 or to a 6, the answer A + B, when A is equal to 3 and B is equal to 6, is 9. Let's see. I can write more math on the page. I can write A - B. I can write A times B and get answers. I can be pretty fancy and write some calculus on the page. And get an answer. Now, when I go back and I change the value assigned to A from a 3 to a 4, all the answers on the page update dynamically. I can change 6 to a 7. And you can see again, all the answers on the page update dynamically. I can even assign to A or B an expression like x + 1. And now x + 1 substitutes for A across the page. So learning math is about seeing connections between things. Here we're looking at the relationship between A and B with respect to some operators, plus, minus, divide, and so forth. By the way, I should pause for a moment and tell you what I'm using here. I happen to be using a Windows tablet, and I'm writing on my screen with a stylus. Everything I'm doing with my stylus on the screen, you can also do with your keyboard, and I'm going to show you how to do that in a few moments. But again, what I'm doing with my stylus on the screen, you can also do with your keyboard, and I'm going to show you how to do that in a few moments. But again, what I'm doing with my stylus on the screen, you can also do with your keyboard, and I'm going to show you how to do that in a few moments. But again, what I'm doing with my stylus on the screen, you can also do with your keyboard, and I'm going to show you how to do that in a few moments. let's go back to what we're looking at here in FluidMath. Learning math is about seeing connections between things. Here we're looking at the arithmetic relationship between A and B with respect to some operators, plus, minus, divide, and so forth. Let's take a look at relationships between other types of things. So here's a mathematical expression, y equals mx plus b. I'm sure we're all very familiar with this. This is the slope-intercept form of a line equation. I've just written it on the page, and with a simple gesture, I can show a graph. I'll do that again. So I've just written y equals mx plus b on the page. FluidMath recognized what I wrote, and with a simple gesture, I can see a graph. You'll notice, since we're all math people, you'll notice that we've selected default values of 1 for m and b, but I can change that. I can assign to m a different value, like a 2 or a 3. I can be more interactive or dynamic by creating a slider for m. And now I can show in a very visual way what slope really represents. What slope? That slope. When slope is negative, it looks like this. When slope is positive, it looks like that. Right, b is the y-intercept. When I change b, I'm changing something. What am I changing? Well, sometimes we learn that b is the y-intercept, but why is the graph moving left and right? If it's the y-intercept, shouldn't it be moving up and down? Well, let's see. Here's the y-intercept, 0, comma b. Put parentheses around that, and we'll graph it. Now, when I change b, now we can see what b, the y-intercept, really represents. So again, learning math is about seeing connections between things. Here, we're looking at the relationship between an algebraic expression and a graph. Too often in the math classroom, the math student, the math teacher, mathematicians in general, always are working on a primary workspace. The primary workspace is usually paper and pencil. The secondary workspaces, or the complementary workspaces, happen to be things like graphing calculators, computer algebra systems, computer simulation systems. It's a different workspace. And all those workspaces have different interfaces. How do you use the calculator versus the pencil on paper? Well, what we're trying to do with FluidMath is hide transparently the technology and bring together in one workspace, paper and pencil, the primary workspace, the mathematics and the representations. So let me show you another example that I really think demonstrates this idea of bringing representations together in one workspace. I'm going to show you a related rates problem. What I need to do is make this a little smaller. That's my Zoom tab there. I am going to do a related rates problem. I'm going to draw 2 cars on the screen here. By the way, I am not an artist. So you'll notice that my cars, these are cars. They look a little funny. This is car A. This is car B. We'll give length to the road. We'll say the road has a length of 1,000 units. And we'll say that car A has a constant velocity of 80 miles an hour. That's a linear function that says the location of car A along the x-axis is defined by 80 units of distance per unit time. Car A is going 80 miles an hour. Car B is a police car that has to accelerate to catch car A. In FluidMath, I press the run button, and we can see the cars move across the screen in an animated simulation as described by the math I just wrote on the page. Pretty cool. Now I can't see your faces and I can't hear you, but sometimes when I show this to folks, adults, teachers, they say, wow, that was really cool. When I show it to kids, their heads explode. They say, wow, make the car go faster, make it bump up and down. All of a sudden, the students are engaged and they're asking great math questions. So now, of course, this is a related rates problem, and there's more than just wow to this problem. With related rates problems, we usually look to answer 2 questions. The first question is usually, at what time does something happen? And at what point in distance does something happen? So the question here, of course, is at what point does the accelerating car, maybe it's the police car, at what point does the accelerating car pass the speeding car? Happens right there. Well, that was an observation, not a math answer. So let's try to find out the answer. Now, if you're smart with math, well, everyone's smart, but if you're an advanced student or teacher, you know that we can set a sub x and b sub x equal to each other, and we can solve for t. right? That'll give you the two intersection points between the parabola and the linear. But I like to explore the answer. I like to use the scientific method to come up with a hypothesis, test the hypothesis, and then prove that the answer is right. So let's graph these two functions and see if we notice anything interesting about the graphs. Of course, we notice that there are 2 points of intersection, the point at which the parabola and the linear intersect with each other. And this point over here, the point at time 8, when the parabola overtakes the linear, is my hypothesis about when the police car or the accelerating car should overtake the speeding car. That happens at around time equals 8. And when the distance is about 650 units of distance. So that's the hypothesis. When time equals 8, the two cars should be at the same spot. So I'm going to run the simulation for 8 seconds instead of for 10 and see if the cars stop at the same spot. If they do, we know we're on the right track. Looks like the car stopped at the same spot. Well, we're just eyeballing the graph. We're eyeballing the simulation. It could be 7.9 seconds or 8.01 seconds. And there's a big distance between 600 and 700 units of distance. So let's prove this. We think that when time equals 8, that the two cars should be at the same spot, meaning that car A should be at a spot near 650. Let's see if it is. 640, pretty close. If B sub x, the location of car X, location of car B along the x-axis is at 640 when time equals 8, then we have proven the hypothesis. 640, pretty cool. So I love this example because it shows the power of having multiple representations in one primary workspace. So when the student asks the question initially, make the car go faster or make it bump up and down, well, we can do that. We can just change the value assigned to A from 80 miles an hour to 90 miles an hour, the expression there. And now look, the graph changed. The point of intersection is a little bit further out. The solutions have changed as well. And the simulation changes as well. The accelerating car does not quite catch up to the speeding car. So I'm going to pause for a moment. I showed you a lot there to consume. I want to see if there are any questions really quickly. Andy, do you see any questions that folks may have so far? Okay, I don't hear Andy. So I will just pop over to the...
Yeah, I'm trying to unmute Andy and the unmute button's not working. So I think there might be a problem with the mic.
Oh, okay.
Here he is. Okay.
Oh.
Yeah, it looks like no questions so far. A few comments, but no questions to stop for. So.
Okay, fantastic. Thanks, Andy. So I'm going to jump. So as I mentioned earlier on, and in the title of the talk, FluidMath is great for. I'm sorry, was there a comment?
Sorry to interrupt. There is one question. It was, is it necessary to use the right arrow rather than an equal sign?
That is a great question. So let me show you what we have here. So think of the right arrow as the solve button on a calculator. It's, the equal sign is typically a symbol that we use in a mathematical expression. So y equals mx plus b, there's the equal sign used in a mathematical expression. The arrow is used for solving. So it's kind of like the solve key on a calculator. Good question. What I just showed you might be utilized by a teacher to make demonstrations. You could capture that in video form, or maybe screencastify it to your students. You could use it during a Zoom session like this when you're sharing your screen in real time with students. But there are also other types of interactions you may have with your students, and those come in the form of being able to share the things that you're doing within FluidMath with your students. So let me show you what I mean by that.
Jan?
Yes?
I'm sorry to interrupt, but there were a few more questions on what you just showed. I don't know if you want to address those or...
Okay, yeah, I'll tell you what, give me one of the questions.
How did you get the cars on there?
Oh, good question. In FluidMath in general, we have two types of pen. There's math pen, and the math pen recognizes math. So when I write math, you can see that underneath the math it's recognized. There's also a draw pen, which allows me to annotate. So I can draw things like smiley faces. Or if I were to write math, you'll notice it is not recognized. So the draw pen allows you typically to annotate things, and the math pen is used to tell FluidMath that I'm writing a math expression. Thanks.
Okay, and there was another question similar to that one about what tool do you use to write on your screen? Maybe that's a hardware question, I think.
Oh yeah, as I mentioned earlier, I happen to be using a Windows Surface device. I'm using a stylus and a tablet Windows device. You could be using a finger. You could be using an interactive whiteboard, like a smart board or an interactive display. You can use an iPad. Chromebooks have touchscreen displays also. And in our web-based version of FluidMath, we have a keyboard interface for entering mathematics. And I'll show you that right now. So we're transitioning to our web-based version of FluidMath. And the great thing about the web-based version of FluidMath is that, well, it's online. It runs everywhere. It runs in a browser. So for example, I can do very much the same that I had done a moment ago, y equals ax squared. All right, I wrote some math on the page, and I can graph. And I'll tell you what, let's make this a little bit more of a fancy expression here. We'll put the full form of the function here, y equals ax squared plus bx plus c. Now we can create sliders for a, and we can explore what a does. Now I'm going to show you something else in FluidMath. One of the things you'll notice if you start using FluidMath is that your handwriting takes up a lot of real estate on the page, especially if you write multiple expressions. So underneath the handwriting right here is a button. And that typeset, the pretty print version of the math, of the handwritten math, is actually a button. So when I click the button, my handwriting will go away and I'll be left with a pretty print version. Okay, so I'm left with a pretty print version. And now I may want sliders on the page. So you'll notice that the A, the B, and the C are blue. So if I click on A, and I click on the B, and I click on the C, I can get sliders for A, B, and C. Oops. And now we can explore what the various sliders really, how they transform the function. Now, what's really cool about what I just did is I created a web page. In no time at all, I created an interactive mathematics web page that I can share with anyone. And I didn't need to know JavaScript or HTML or any technology other than mathematics and logging into FluidMath to do this. So I can take this, and this looks like an interesting activity about transformations of functions that you might share with your students. In fact, you might add to the page a text box with some instructions at the top, something along the lines of, I'll make this big and bold so you can read it, and I'll make it underlined. Transformation of a quadratic. Okay, and then I might put an instruction for my students, play with the sliders to understand parameter transformations. Okay, so I have just created, and I'll make the text box a little bigger so we can see the instructions. In just about a minute, if I weren't talking, it would be less time. I created a really cool activity that I can now share with my students. So I am going to save this as, I'll call this activity one. Activity one. So I save that as a FluidMath doc. And now I can do, under the More menu, I click on the Share button, or the Share menu item, and I've got a URL. This URL I can paste into an email or Google Doc or anywhere else that someone might click on it, my course web page, for example, and I can paste that into another browser. So I'm going to pop up another browser here on the right-hand side, and what we'll do with this other browser is that we will we'll open another tab here, and I am going to move the zoom thing. So I'm going to paste, I took the URL off the right-hand side browser, and I'm going to paste it right over here into the left-hand browser. And now all of a sudden, that really cool activity created on the right-hand side can be shared with anyone over here. So you can share this with your students. And by the way, you do not need an account to see these activities. So if you have a course webpage that's open to the public, you can create lots of these activities and just share them with folks, share them with your students or anyone on the web, and they can access these and play with them. And again, these can be arbitrarily complex. So when we initially built this, the teachers who were using it said, this is great. I can create my own cool interactive activities and I don't need to know JavaScript or HTML or any technology. But can you guys do us a favor and make them a little bit better? And we said, well, how could they be better? And the request was, well, can you make these more like assignments where I can hand these out to students? They can show their work on the page and maybe put an answer on the page, and then they can submit the work and I can review the work that they've submitted, give them some feedback, and then hand it back to them. And we said, sure, we could do that. So let me show you what we did, and this is really cool. So I am going to create another FluidMath document. So I'm going to open up another FluidMath document here, and we're going to create a very simple assignment, and it'll be based on this math expression, y equals 2x plus 3, and obviously the slope-intercept form of this line equation, where 2 is the slope and 3 is the y-intercept, and we'll put a graph on the page, and I am going to zoom the graph. So that I'm doing a pinch zoom with my fingers right now because I want to be able to see the y-intercept. And I'm going to shrink my handwriting so I have a more well-formatted math on the page. And the next thing I will do is I will insert 2 questions on the page. So I'm going to insert question number 1 here, which is, and I'll make it big and bold so you can see it. What is the slope, the equation below? Okay, that's question number 1. Question number 2 will be related to the y-intercept. So I'm going to make it bold and big. Review this. What is the y-intercept? And I'm going to be very clear by specifying the b value because I know some students might want to enter the coordinate pair. Some students may want to enter the b value, but to be explicit here in our question, we'll say, what is the y-intercept in the graph? Of course, there are other ways to ask the question explicitly, but the answer I want is just 3. So now, this is great. You could probably create this in Google Docs or in Microsoft Word. You wouldn't have a math editor, and you probably wouldn't have a an interactive graph to explore with. But you can do this. But this is what you can't do anywhere else. This is really cool. So I'm going to put on the page a math answer box. And in the math answer box, the author, or the teacher in this case, can put an answer on the page. But when I distribute this to the students, and you'll see this in a moment, the students will not see the answer. So what's the slope? The slope is 2. What's the y-intercept? The y-intercept b value is 3. So I'm going to save this now and click on save. And we'll call this quiz 1. Maybe homework assignment 1, we'll just call it quiz 1. Save that. Now I've saved it. I created a quiz in just a matter of moments, and now I've saved it, and I'm going to distribute it to all of my students in my class. So I've got a classroom here called, I go to the More menu, say add to classroom. I've got a classroom I can assign this to. My demo classroom that I use for demonstrations like this is called Answer Box Examples. So I click on Answer Box Examples, and then now the quiz or the homework assignment has been distributed to all of the students in my classroom. So let's take a look at what the student sees. On the left-hand side, the browser represents the student's computer or system. So on the right-hand side, that's the teacher. On the left-hand side, this is the student on a different computer, maybe at home. The student goes into Answer Box Examples classroom, and here are all of the assignments that have been distributed to the students across the school year so far. And down here at the bottom, we can see quiz 1, never been visited. That's the one we just created. So I'm going to click on quiz 1. And now you can see what the student sees. This is, of course, the student cannot see the answers because they have to come up with the answers. So the student may turn on their annotation pen, and they might mark up the page. This is to show their work. What's the slope in the equation? The slope is 2. So m equals something. Let me just go look at the graph and annotate the graph. Up 2 over 1, up 2 over 1. Okay, so the slope must be 2 over 1. Okay, so I'm going to write the answer in 2 over 1. And we can see the system comes back and recognizes my 2 over 1. And then we see what's the y-intercept? The y-intercept is 3. I'm going to get this question wrong. I'm going to get the answer wrong here so you can see how the system handles wrong answers. Now, of course, this is like a piece of paper. So the student can write more math on the page and the student can doodle on the page. And then the student submits the work. Let's see what the teacher gets after the. So now we're going to look at the teacher screen. We're going to go to the teacher's classroom and we'll go to the FluidMath documents. And now the teacher can look at all of the assignments that have been distributed across the school year to all of the students. We'll go down to the bottom here and we can see that this student here submitted some work. They got a 50%. So the system automatically graded what the student submitted. We can see that there are other students here who haven't submitted work yet, but now the teacher can go look in at the quiz that was submitted. We can see only one student submitted work so far, 50%, because they answered one correct and one incorrect. The time it took to do the work was 61 seconds, and it was submitted 30 seconds ago. So as the teacher, let's take a look at the assignment that the student submitted. So now, this is what the teacher sees. I've just expanded the screen so we can add some feedback for the students. So the teacher may turn on their red markup pen, and maybe the teacher gives the student some feedback. The teacher may down here write a comment about that answer and say, close. And then, up here, the teacher may write, another comment, good job. But maybe the teacher wants the student to do the work again. So this teacher writes another note, try again. And puts a smiley face on the page for the student, and then sends the feedback to the student. Feedback to the student. Let's take a look at what the student gets. So again, on the left-hand side, this is the student. So the student is going to look at that quiz feedback from the teacher, and now the student can see the feedback from the teacher. So the whole life cycle of what used to be for me, because I'm a little bit older, a piece of paper was handed to me. It had some math questions on it. I answered the math questions. I submitted them back to the teacher. The teacher marked them up, handed it back to me. I got a grade. I stuck the piece of paper in my backpack. Who knows where it went after that? But it's the same paradigm, but better in a couple of ways. Number one, super easy to create these. They are self-grading and they're digital, easy to distribute, and there's no paper involved. And they remain in the system forever. So you can always go back and review them as a student or as a teacher. If you have a parent-teacher conference, you can go back and show off the great work of some of the students in your class to their teachers. So I'm going to pause for just another moment here and ask Andy if there are any additional questions that showed up in the chat room.
Hey, Don. Yes, we have a couple of questions. First one, could I download a problem and have kids draw on it and have them collaborate on it?
That is a great question, and I'm going to answer that question in a moment because I'm going to show you some more functionality that basically answers both of those questions.
Okay, I'm going to go fast because I think you're coming up on your time as well. So do the kids have an account? Do the kids have to have an account to do the activity?
The kids need an account if they are going to write math on the page. To play with sliders and to interact with the graph, no account is necessary, but to write answers and to write math on the page, yes, the kids need accounts.
Can a person who has a copy of the page change anything on that page, or are they limited to the sliders?
Good question. So if you want to share, well, there's a couple of different scenarios. You may be a teacher who wants to share your examples with another teacher, and you can do that. And the teacher will get it, and they can they can download it, or well, it's not really downloaded. They can get it, get access to it, make a copy of it, and then edit it, change it. If you are giving this out as an assignment in the way I just did through the classroom mechanism, the students cannot copy it and edit it and change it.
Okay, I teach 6 to 8 math and pre-algebra. Does the site work for middle school geometry, statistics, etc.?
Good question. In the interest of full disclosure, we don't do a lot of geometry and we don't do a lot of statistics yet, but stay tuned and you may see some of that in the near future.
Does this integrate with Google Classroom, distribute to the students in my Google Classroom?
That's a great question too. Right now, we do a very simple integration with Google Classroom. So for example, you can copy any of these URLs and paste them into Google Classroom. Into Google Docs, you can, I think, also embed them so that they might actually show up sort of a lot. But there's a deeper integration that we plan on doing in the near future, which connects the grading and the rostering and so forth with Google Classroom. So stay tuned on that, please.
When you ask them to try again, does it replace the grade or show an additional attempt with a new grade?
It shows an additional attempt with a new grade. And
last one, I think for now, can I import questions from a library?
Good question, and I'm going to show you a little bit of that right now. So there were a couple of questions that were great leading questions onto the next couple of things I'd like to share with you. So let me jump right into those right now. As a teacher, you are aware that you don't have a lot of time. And creating quizzes like this, although interesting and attractive to you sometimes, may not be something you always want to do. And you may have a lot of, in fact, you probably have a lot of PDF files sitting around that are problem sets or worksheets that you want to be able to share with your students, and you've always shared with your students. So let me show you this pretty cool functionality here in FluidMath. So I have a folder full of homework assignments over here, and these are my template homework assignments. And I'm going to just open one in Acrobat Reader. So solving systems of equations. We'll open that. And you'll see that this looks like any other PDF file that you might have. It's a homework assignment. It's got some math questions on it. It's about solving systems of equations. It's got an answer sheet on it as well. But let me show you what you can do. Normally, you'd print that out on paper and you'd hand it to your kids. But what you can do with FluidMath is you can drag and drop. So I'm going to take that PDF file and just drag and drop it right into FluidMath. And now that PDF file becomes the background for my FluidMath page upon which I can do all of my cool FluidMath stuff. So I can write math. So, y equals x. I can write math on the page. I can graph. I can annotate. So, I might step through this problem here and show my work. So it's, it's minus 8x minus 2 times minus 6x 4 equals 0. And then obviously I can continue showing my work on the rest of the page. And in the same way that I did before, I can submit this back to my student, back to my teacher. But as a teacher, you can also add these math answer boxes to the page, which allow you, and let me just get rid of this really quickly, which allow you on the blank sheet of paper here to enter, maybe the answer is 2, 3. I don't know, I didn't solve the answer, so I don't know what it is, but I'm just giving you an example. If you know what the answer is, you can put that on the page. So now, all of a sudden, what was a static PDF file becomes a live, dynamic, self-grading assignment that you can hand out to your students. Pretty cool, I think. Now, of course, this is awesome, but we can even take this one step further. So a new bit of functionality that we have been adding to FluidMath. We haven't shown this to a lot of folks, but it's coming out very soon. So I'm happy to share it with you because I think it's very apropos to the current situation that you're facing in terms of working with your students online. We call it math worksheets for the moment. We may change that to problem sets or practice or something. But if I click on math worksheets here, I get to see activities across pre-algebra, algebra 1, and algebra 2. We'll be adding more topics as time goes on. Let me pick a couple of examples in algebra 1. So I'm gonna maximize my screen here so you can see what I'm doing. So over here I picked a topic. We pick algebra 1, and I am going to pick a couple of topics within algebra 1. Since I just showed you a systems of equations, we'll do another one. Systems of equations, and I'm going to pick systems by substitution and by elimination. You'll notice on the right-hand side of the screen pops up some parameters that I can specify. These worksheets. I'm going to put 2 questions per page, two questions of each type on the worksheet, and I'm going to give a little scratch space between the question and the answer. This is the space between, the scratch space that the student gets to work in between the questions. Now, of course, down in the lower left-hand corner, if you want to go back to creating PDF files, you can create PDF files. But I'm going to create a FluidMath document. So this button down here on the bottom is a FluidMath document. I click on the FluidMath document, and now we can open up what looks very much like a worksheet, but what's really cool here is that it's got these answer boxes in it. And these answer boxes, when you now, and in the same way that I did before, if I save this and then I distribute it to my students, I've got an automatically generated worksheet with random questions on it that I can hand out to my students, and they can show their work, and the system will automatically grade the answers. So I'm going to show you a couple more things here. That's pretty cool. Let me just jump, since we're almost out of time, I want to answer the other question related to sharing the page or collaborating with students or with other users, or having 2 students collaborating at the same time. And imagine if the FluidMath page could be shared between multiple people in real time. Well, that's what collaborative FluidMath is all about. So on the right-hand side, I am a teacher, and on the left-hand side, I'm a student. And the teacher on the right-hand side starts up a collaborative FluidMath document. And this is basically a collaborative whiteboard for mathematics. So on the right-hand side, I'm the teacher, and I've opened up this collaborative document that I want to share with the student on the left-hand side. So under the More menu, I click on Share, and I select the student name. If the student name isn't here, I just type their name in, but I click on the name, and now the student on the left, this browser, the student's computer, and by the way, this could be multiple users. It doesn't have to just be 2. So now when the teacher on the right-hand side writes a math expression, it shows up in real time on the left-hand side. Not only does it show up, it's alive. So the student on the left-hand side can edit it. So initially I wrote it on the right-hand side, and I edited it on the left-hand side. So you can imagine the teacher-student interaction where the teacher and the student are working through math problems together, or the tutor and the student. And of course it's alive, so you can create, it's a FluidMath document. There's also an opportunity to do collaborative problem solving between students. So I'm going to start, again, FluidMath on the right-hand side, and instead of this being a teacher and a student, this is going to be 2 students working together. So I have an example that the teacher gave out to the students. And so in this teacher's classroom, the students are working in pairs. The student on the right is going to work with the student on the left. This could be, it doesn't have to be pairs, it could be 2, 3, 4, 5 students, it could be any number. So the student on the right is going to share this document with the student on the left. So the student on the right clicks the student's name on the left. Now these 2 students are sharing the same document at the same time. So when the student on the right writes a math expression, the student on the left can see it, but the student on the left can also edit it. But let's take a look at this specific example. The point of this example is that the first student is to write the line equation that goes through A and B. The second student writes the line equation through B and C. The third student through C and D, and so forth. Since there are only 2 students here, the students will alternate. So the student on the right says, I'm going to go first. And the line equation that goes through A and B must be y equals -4, because all the line equations begin with y, and the a is right next to the -4, so that's got to be it, right? So the student on the left says, well, I don't know if that's right or wrong, but I know how you can test it. So the student on the right is the one who wrote it. The student on the left can graph it. And now the student on the left says, well, your graph doesn't go through A and B. And the student on the right says, well, what did I do wrong? And the student on the left says, well, not all line equations begin with y equals. It could be x equals -4. And the student on the right says, oh, now I can see that my line equation goes through A and B. And I can write my answer into the answer box, x equals -4. And the system comes back and that to be -4. And the system comes back and gives immediate feedback. Not only immediate feedback, it also under the check mark you can see there, it indicates that the student, which student entered the answer. So the student on the left says, oh, thank you for the, the student on the right said, thank you for the answer. The student on the left says, I'm going to answer question 2. And the student on the left knows the answer is y equals -x, y equals -x minus 2. And the student on the right says, I don't know if that's right or wrong, but you taught me a valuable lesson. I can graph the function to determine if it's going through B and C. So the student on the right graphs it. Cool, it goes through B and C. So the student on the left says, I know I was right, and the student on the left writes in the math expression y equals -x minus 2, and the system comes back with an answer indicating, with check mark indicating that the solution is correct. So I am just about out of time, so let's take the next few minutes and answer some questions from the folks listening here. Any more questions?
There aren't any new ones, Don, but there was an earlier one back when you were doing the car example in the beginning. And the question was, on the website, there are different product lines. Which one did you use for the cars?
Oh, that's the FluidMath application that is the Windows-based application. It installs on your Windows device. It's a Windows-based application again. But you can also do the animations in the web-based version of FluidMath. So I'm going to do an animation really quickly in the web-based version of FluidMath. So with the draw pen, we'll draw a couple of cars. And we'll draw a road. And with the math pen, I'll label the cars. And we'll label the road. And we'll write the math expressions that we just saw. It's slightly different in the web-based version. So in the web-based version, what we want to do is we want to turn on the animation capability. And the animation capability can be accessed or turned on under the More menu. There is animation math sketching. So I select that. And you'll notice that the math expressions become color-coded and that what looks like a slider or a number line pops up. That's actually sort of like the VCR controls for the animation. There's a play button on the right-hand side. I click that button, and now the cars move across the screen. So similar functionality in the web-based version as in the installed version.
Okay, another question is, does it work for Macs?
Yes, one of the things I mentioned early on was that we have a keyboard interface to FluidMath. And I know a lot of Macintosh computers, so it works great on iPads if you're using the pencil or you're writing with your finger, because it's just running in a browser. But you can also use a keyboard to enter math notation. So I'm going to switch over to math entry mode of typing, and I am going to type some math. So I can type y equals ax squared plus bx, right? The thing that's a little tricky about using a keyboard is that you will want to use the insert menu to put a graph on the page. And then you can drag and drop the math that you just typed on the page into the graph. Now you can also, I used my physical keyboard to enter math notation. There's also a soft keyboard on the bottom. A soft keyboard is where you pick and peck at the buttons and you can put more math on the page. So I'm going to use the soft keyboard to put more math on the page. And then again, I can drag and drop that onto the graph. And by the way, you can have multiple graphs on the page too. So if I wanted to put another graph on the page, I can do that. And I can type over here, y equals ax cubed. And we can drag that onto the graph. And now we can have multiple graphs on the page. All right, any other questions?
Question, is all of the software free for teachers?
We're offering FluidMath for free for all teachers and students through August 2020. And the way to get there, and I'll put the slide up again at the end, is to go to fluidmath.net. There's a free trial button on fluidmath.net homepage. Click that, enter a promo code. In the promo code field, it's called, the promo code, you can see it on the screen there, Math UnConference. That's where we are today, the Math UnConference. And if that's for individual licenses, if you happen to be a teacher with a classroom full of kids, or an administrator in a school, or at a district level, and you're interested in more than just one license for yourself, or a trial for yourself, if you'd like to get it for your classroom, or for all the students in your classroom, or at your school, or in your district, please email info@fluiditysoftware.com, and you will be able to see, we'll get in touch with you and we'll set you up with your classroom licenses.
I wonder, there's a few more questions coming, like, can you draw the graph and will the software recognize the equation?
Can you draw the graph? Well, that's a great question. We have an application, it's called Sketch to Graph. It comes with the FluidMath license. When you get an account, you get Sketch to Graph. It allows you to draw into the graph and see the math expression that relates to what you drew. You can also, the functions or the plots have handles on them, so you can move the graphs around and see the equations change as you manipulate the graphs.
Next question, if you buy a teacher subscription, do the students need to buy one as well?
Yes, the subscriptions are on a per user basis. So, and also with regard to, so keep in mind that the subscriptions are free through August 20th. But if you're thinking long-term, when you purchase FluidMath, the most common version of FluidMath that's purchased is webFluidMath. And the pricing on the site you can see, but as the volume increases, the price decreases per user. There was a question about social media, and the answer is yes, we will be much more active in the near future on social media. And you can reach us at FluidMath. So on Twitter, it's @FluidMath, and on Facebook, it's FluidMath. YouTube, it's youtube.com/FluidMath, and we also are on Instagram. Oh, thanks. The animation example always catches folks' eyes. It's kind of fun to show. I find it fun to demo. And I think it also connects a real life example that kids are familiar with, driving a car, with mathematics. I think kids, when you say related, we're going to do a related rates problem, sometimes if you stick to only the math, the algebraic notation and the graphs, maybe it doesn't really register with the kids. But as soon as the kids can start playing with it, in fact, we've had kids at as early as fifth grade play with that animation example. And even though fifth graders don't really know much about algebra, and they certainly don't know about quadratics, man, do they get a kick out of playing with it. And then it's also an opportunity to introduce other mathematics, like how do you make the car bump up and down? Well, there's a function they'll learn about way later in high school called a sine function or a trigonometric function, like a sine curve, where you can then specify a vertical translation a component to your animation, and then the car will bump up and down. It's really cool. It's fun to see the kids play with it.
There was one question that came in about sort of the device compatibility. So what devices does FluidMath work on?
FluidMath works on all devices. In fact, I'd say the majority of our users happen to be students who are using Chromebooks, and many of those are not touchscreen Chromebooks. So even though you think FluidMath appears to be a very touch-centric and a pen-centric application, it also works just as effectively with keyboard and mouse. So it works everywhere.